All right, welcome to another edition of Science in Pajamas School Edition. Today we're going to be looking at another one of my physics class labs. This way, any student who's absent or unable to do it in class will be able to still see the lab, still be able to collect the data, and still kind of see the real-world applications of it, and still be able to complete the lab from home. Now, this lab is called Rolling Momentum Lab, and the point of it is for kids to be able to calculate the momentum of three objects that are rolling down a ramp as they collide with another object, in this case, a cup. So I'll go ahead and show you the setup, and then we'll go ahead and perform the lab. So it starts up here where we have our ramp. So it's a ramp set up on some textbooks. And then we have our three balls. We have a golf ball, a ping pong ball. It's a different kind of ping pong ball. It was the only kind I had. It was a small Halloween one. And then a marble. Now, as the ball starts at the ramp, it'll roll down into our setup down here. Now, this is the setup at the base. Here we have our cup. This is what they will collide with. Now, you'll notice the tape here measures the starting point of the cup. As the ball hits or enters the cup, that's actually when we're going to start our timer. When it enters the cup, it'll hit the back of the cup and cause the cup to move. When the cup moves, obviously it's going to move away from the starting position. When the cup stops moving, that's when we will stop our timer. We will then measure how far away from the starting position the cup has moved. That'll give us our distance. And we'll do that 3 times for each of the balls. So we'll have 3 times and 3 distances. We'll then find, the student will then find the average time and the average distance for each of the 3 balls. Now, once they're done with that, they'll be able to use the average distance and the average time to find the average velocity. Now, to find momentum, you need mass and velocity, because momentum is mass times velocity. So, to help with mass, I went ahead and found those already. So for the mass, now these are in grams, these are not in kilograms. You will have to convert these to kilograms in order to do the calculations correctly. But here are at least the masses in grams. The marble's mass is 5.41 grams. The golf ball's mass is 45.12 grams. And the ping pong ball's mass is 3.36 grams. So those are the masses in grams. Don't forget to convert them to kilograms for the assignment and for your calculations. All right, now let's go ahead and get started, shall we? Just angle this down so you can see. All right, so I'm going to put the cup in the starting position. We'll go ahead and start with the ping pong ball. Get that out of the way. Oh, let me get my phone out so I can do the time. Okay, stopwatch. Just make sure it's lined up properly. Okay. And trial 1. All right. Here was the first time for the first trial for the ping pong ball. So that's time 1, 0.23 seconds. And the distance the cup moved was, let's see. Okay. So the distance it moved was, I'll show it to you. I know it's a little hard to see, but it's about 4.5 centimeters. Now you'll have to convert that to meters, but 4.5 centimeters, convert that to meters. So that'd be 0.045 meters, in case you forgot. All right, let's go ahead and do the next one. Yeah, we'll reset. Set. Okay, there's the time for the second trial, 0.18 seconds. 0.18 seconds for trial 2. And our distance was 4.1 centimeters. 4.1 centimeters. Don't forget to convert that to meters. 4.1 centimeters for trial 2. Convert that to meters. All right, let's reset. Okay. Trial 3, 0.15 seconds. 0.15 seconds. And the distance, about 4.1 centimeters again, 4.1 centimeters again. All right, so again, don't forget to convert the 4.1 centimeters to meters. All right, so those are all the data we need for the ping pong ball. You'll have to take the 3 distances, find the average, the 3 times, find the average. You can then find the velocity. Use the velocity and the mass to solve for momentum. All right, let's move on to the marble. All right, now this is a little bit of an issue sometimes. As much as we don't want to have to change anything, we do have to sometimes compensate. So it's not the perfect scientific thing, but we do want to prevent the cup from falling over. So I'm going to put a is not perfect science. I know I'm changing the system a little bit. It's not the best, but I don't want the cup to fall over. Oh. You know what? Why don't we just measure it with where it rose? Because we really don't want to change the mass. Okay. So 0.28 is our time. 0.28 is our time, 0.28 seconds for trial 1, and 15 point, wait, sorry, let me line that up properly. 15.3 centimeters is our distance, 15.3 centimeters. Don't forget to convert that to meters. Okay. let's do trial 2. Oops, I didn't hit stop in time. Sorry about that. I'm not perfect. I've accepted this. Okay. 0.28 seconds again. 0.28 seconds again. And 8.6 centimeters, 8.6 centimeters. Don't forget to convert that to meters. 8.6 centimeters. All right, let's do trial 3. Okay. 0.36 seconds, 0.36 seconds. And the distance is 9.4 centimeters. 9.4 centimeters. Don't forget to convert that to meters. All right, so that's all the data for the marble. Don't forget to take the 3 distances, find the average, the 3 times, find the average. Use the average distance, average time to find the velocity. Use the velocity and the mass and to find the momentum. Now this is the tricky one, the ping pong ball, because it is heavy. It is going to knock the cup down. So we're going to have to wait or see where it goes. It might even knock it off the table, so let's see. Okay. 0.78 seconds. 0.78 seconds. The ball did go off the table. The cup did not. But there's our time. Let's get our distance. 57.1. 57.1 centimeters is our distance. 57.1. Don't forget to convert that to meters. Let me go get the ball back. All right, let's reset for trial 2. Okay. 0.66 seconds, 0.66 seconds. Again, the ball went off the table, but the cup did not. It kind of rotates the cup, and it falls out the opening. But 0.66 seconds. Let's get the distance. Uh, 67.9 centimeters. 67.9 centimeters. Don't forget to convert that to meters. Let me go get the ball. All right. Sorry about that. The screen went dark. All right, let's do the last trial. Sorry, I forgot to hit stop. I was so enthralled with watching it roll together off the table. Try that again. Sorry, he's doing some pretty interesting rolling things. I'm not doing very good on this round. I apologize, you guys. I'm also not exactly sure when to hit stop on this one because it'll like just sit there and roll in a circle. Well, the cup's not done moving, but it's not really going anywhere. Okay. So it was 1.11 seconds, 1.11 seconds, and the distance uh, 65.3 centimeters, 65.3 centimeters. It just kind of kept spinning in a circle at that point, hence the longer time, but 65.3 centimeters. So now you have all the data. You take the three distances, find the average, take the three times, find the average, use the average distance and time to find the velocity, use the velocity and the mass to find the momentum. And then you're all done with the calculations. You can then answer the questions and finish up the lab. Well, I hope this helps you to, one, complete the lab, yes, but also just help you to kind of understand the ideas of momentum a little bit more. All right, if you have any questions, feel free to email me, my ducklings, and hopefully this was just a good learning experience. But in the meantime, take care, stay safe, and I will see you later. Take care, ducklings. All right, bye-bye.